Okay, so scalars and vectors. So the difference between them, a scalar is a quantity, so something you measure that has a magnitude but no direction, whereas a vector has both magnitude and direction. So an example of a scalar would be something like distance. You could also put speed. You could also put temperature. For vectors, these are things which have direction as well. So a vector would be something like displacement. That's the vector equivalent of distance or velocity. Or even acceleration, which we'll come across later in the course. What's important with vectors is you need to be able to add vectors together. So we'll look at addition of vectors, and first of all we'll look at parallel vectors. So let's say we have two parallel vectors going in the same direction. We'll call the top one v1, the bottom one v2, and we want to work out the resultant vector, so both of these added together. The resultant is just going to be both of these lengths added together, so it's just going to be a longer vector in the same direction. We'd call that v1 plus v2. That's the resultant. Now if they were going in opposite directions, so let's say v1 was going to the right, but v2, let's make that slightly bigger, was going to the left, then the working out would be slightly different. Even though you're adding them, v2 is technically negative. So what you'll do is you'll subtract the two, and what you'll get is the overall resultant vector will be pointing to the left because the v2 is greater than v1. So whatever the difference in length is, that will be the size of the resultant vector. So your resultant vector would look something like this, and it will point to the left, and that will be known as v1 minus v2. Now where it gets trickier is when you're dealing with perpendicular vectors. So let's draw an example. v1 is going upwards and v2 is going to the right, like this. So both of these are perpendicular to each other, and what you want to work out is the resultant force of both of these. So what you need to do here is you need to draw both of these vectors tip to toe. So that means the end of one vector needs to join to the start of the other vector. So the start of v1 would be here, and the end of v2 will be to the right. So imagine moving this across like that. So if you want to work out the resultant, that's basically the distance from the start of v2 to the end of v1. So it'll basically be this. We'll call that r, the resultant. So now you know you have a right angled triangle. You should know from maths that to work out r, what you need to do is use Pythagoras theorem. And what Pythagoras theorem states is that your v1 squared plus your v2 squared should equal to your resultant squared. Now remember, this is a vector, so not only should you give the magnitude, so Pythagoras theorem gives you the magnitude, you also need to be able to work out the direction of this resultant force. So we'll call the angle theta. The direction is given by an angle theta. And to work out that angle, you need to use trigonometry. So we're dealing with a right angle triangle. We know what v2 and v1 is already. So what we can do is think of v1 as opposite to the angle and v2 as adjacent to the angle. So we've got opposite and adjacent. So from trigonometry, if you use SOHCAHTOA, you would remember that opposite and adjacent gives you tan. So what you can say is tan theta is equal to opposite over adjacent. So our opposite is v1, so it's going to be v1 divided by our adjacent, which is v2, because that's what's adjacent to the angle. Therefore, we can work out the angle by moving the tan to the other side, and to move it to the other side, you use tan inverse. So tan inverse v1 over v2 should give you the direction of your vector. So next up, we need to look at how to resolve vectors. So resolving vectors is basically the reverse of what we've just done. So let's say we have a vector going in this direction. We'll call that v. What you can do to any vector is you can split it up into two components, the horizontal component and the vertical component. Okay, so the horizontal component we'll call Vx, and the vertical component we'll call that Vy. So any vector can always be split up into these two components. So let's say that V is going at an angle theta in that direction, and we want to work out what the horizontal component is and what the vertical component is. So to work out the horizontal component Vx, again, we need to use a bit of trigonometry. So we want to work out what Vx is. We know what V is. Remember, V is the hypotenuse, is the longest length in the triangle. We also know what theta is, because we should know that from our starting vector. So our Vx, you can think of it as adjacent and the hypotenuse. So if you go back to SOHCAHTOA, you'll know that that's adjacent over hypotenuse. So you can say cos theta is equal to adjacent, which is Vx, divided by hypotenuse, which is V. So our equation for Vx, our horizontal component, is V times cos theta. Now for the vertical component, Vy, we're dealing with the opposite and the hypotenuse. So that's going to be sine. That's going to be Vy over V. Move that to the other side, we get our equation for the vertical component. Vy is equal to V sine theta. And that's how you work out the vertical component. Alright, so let's look at an example to show how to work these out. Okay, so an object is traveling at 5 meters per second at an angle of 60 degrees to the horizontal. Find the horizontal and vertical component. Okay, so let's draw the vector first. 60 degrees to the horizontal. Let's say that's the horizontal. This is 60 degrees, so that's our theta. And it's moving at 5 meters per second, that's our magnitude. So 60 is our direction, 5 meters per second is our magnitude. We want to work out the horizontal and vertical component. So that's basically, this is our horizontal component, Vx, vertical component is Vy. So if we want to work out Vx, then again, that's going to be adjacent and hypotenuse, so that's going to be cos. So we can say that Vx is equal to 5 cos 60, which gives us an answer of 2.5 meters per second if you put that in your calculator. Vy, this is going to be sine because it's opposite and hypotenuse, so sine 60 is equal to Vy over 5. You rearrange that, you get 5 sine 60, and that gives us an answer of around 4.33 meters per second. Alright, so we're going to look at an example of finding the resultant of more than two vectors. So let's say we have 3 different vectors. So let's say 3 different forces coming from the same point. So we've got one vertically up, we got one horizontally to the left, and then we've got one going at an angle in this direction. Okay, so let me just draw the axes. This is the horizontal axis. This one is traveling at 20 degrees to the horizontal. It's going underneath the horizontal. Let's say it's got a force of 4 newtons. This one has a force of 3 newtons, and this one has a force of 5 newtons. And we want to work out the resultant of all 3 of these forces. So the best way to do this is to look at the horizontal and the vertical components of each one separately. So let's start off with the 5 Newton one. So horizontally, that's going to the left by 5. So usually you take the right hand side to be positive. So if we do it that way, that means the 5 newtons will be negative to the left. So this would be minus 5. In the y direction, because this is completely horizontal, the y component of this force is 0 because it's going completely to the left. Now let's look at the 3 Newton one. So horizontally, this will have a component of 0 because again it's going completely vertically up, whereas the vertical component will be 3 in the positive direction because it's going upwards. That's what we usually take as positive. So negative will be downwards. So those two are fairly straightforward. The harder one is when you look at the 4 Newton one. So let's start off with horizontal. Now if you think back to SOHCAHTOA, when you're dealing horizontally, this is our x, this is our Vx, this is what we're trying to work out. This is our hypotenuse. Our hypotenuse is 4 newtons. So it's going to be 4 cos 20 for the horizontal component of this. If we want to work out the vertical component, so you can think of the vertical component as basically this length of the arrow. So that would be our Vy. That would be, again, this is the opposite. This is the hypotenuse. Our hypotenuse is 4. So our Vy is going to be 4 sine 20. And that will give us the vertical component of that one. What you should also remember is the vertical component is downwards. So this should actually have a minus on it. So it should be minus 4 sine 20. Okay, so once you've done all of that, you add up your horizontal components and then you add up all your vertical components. And you should get minus 1.24 here and 1.63 here. So we've now just worked out the overall horizontal component and overall vertical component for these 3 vectors. But that's not the complete answer, because remember what we're trying to work out is the resultant of all 3 of these. So now we can look at how this would look like if we just had 2 vectors. So we have one vector with a horizontal component of minus 1.24, so that would look something like this. It would go to the left because it's a minus, and then we've got something vertically, because remember that's the vertical component, going upwards at 1.63, and I've drawn these tip to toe as well. You want to work out the resultant of these two, so you just basically want to work out this. Don't forget you also need to work out the angle if you want to work out the magnitude and the direction. So to work out r, you do Pythagoras. So r squared is equal to 1.24 squared plus 1.63 squared. Therefore, to work out r, you need to square root all of that, and you get a magnitude of 2.05 newtons. And to find the direction, then you need to use trig. We got opposite and adjacent. So this is adjacent and this is opposite. So it's going to be tan. So you can say tan theta is equal to 1.63 divided by 1.24. And to work out theta, you rearrange that. So you do theta is equal to tan inverse all of that, 1.63 divided by 1.24. And that should give you an answer of 52.7 degrees. And for your answer, what you should really say is 52.7 degrees to the horizontal, because it's not to the vertical. Remember, you're taking an angle from the horizontal axis.
For more videos like this, summary videos, worked examples and exam tips, subscribe to my channel.